Right, so we got this problem about a car crashing off a cliff. The car was found crashed at the bottom of the cliff, and we know the height of the cliff is 124 meters high. The car is 64 meters away from the base of the cliff. And we want to figure out how fast the car was moving if we know that it left horizontally. So first step right here is draw and label a picture. So I'm going to draw a picture of a car driving off a cliff. There's the car. There's the cliff. When it leaves the cliff, projectile, so it's in the shape of a parabola. Here's the crash site here. And we know a few things. We know the height of the cliff is 124. We know the distance away from which it landed was 64 meters away. That's the range. And we also know that it was traveling with some horizontal velocity, and we'll call that Vx. And we don't know. That's what we're trying to find out. So now that we've drawn and labeled the picture, we now have to start with our X and Y table. We treat X and Y completely independently. So our X variables are Vx, D, and T. Those are the only three things that we have going on in the horizontal direction. Vx, we don't know. So we put a question mark there. D, we know, 64. And the time we don't know, so there's a question mark there. So two question marks mean we can't do anything on that side. So we have to move to the Y side. We also have three variables in the Y direction. It's H, G, and T. Again, if we don't know T over here, we don't know it over here, so there's a question mark. We do know how high it is. It's 124 meters high, and our acceleration due to gravity is always going to be negative 9.8. Now we have two out of these three numbers, so we can use an equation over here. The equation we use over here to get that is H equals the absolute value of 1/2 GT squared. And we are finding time. That's the third step. Third step here is to calculate time, and you can get time either in the X or the Y. Since we can't get it in the X, we have to get it in the Y. So if I come up here and do my work, I know H is 124 equals 1/2 times 9.8 times T squared, and I just drop the negative because it's an absolute value. And I do some quick math, and I get, that T is equal to 5 seconds. 5.0 seconds. So, in other words, the car spent 5 complete seconds in the air from when he left the ledge to when he crashed. I can plug this time right here into both my X and my Y because that is the link between the horizontal motion and the vertical motion. So not only is this 5.0 seconds, this is 5.0 seconds. Going to step 4, I use my time to plug in to solve for what you're looking for. So in this case, we're looking for Vx. I've got two numbers here, and I've got one unknown here. There's only one equation that we ever use in the X direction, and that is distance is equal to the velocity times the time. Because in the X direction, it's constant motion. We don't have to worry about any acceleration. 64 is equal to the velocity, which is what we're looking for, times the time, which is 5. And when we divide both sides by 5, we get 12.8. So the velocity is 12.8. It's a velocity, so it's in meters per second. So in this problem, the car was moving at 12.8 meters per second. It spent 5 seconds in the air, and it fell down 124 meters and over 64 meters. That's pretty much how you approach any of these problems. Really the only difference is sometimes it's going to be asking you for a velocity here. Sometimes it might ask you for how far over did it go. Either way, you've got to get time, and then you plug it into this equation to get